Hello everyone, I'm Abhishek Dubey. We are currently working on our final year machine learning presentation, and in that we got into a Kaggle competition, namely cervical steel detection. It is basically classification problem of detecting which kind of defect a steel would be having. Now let me introduce you to the competition and tell me something about it. Cervical is leading the charge in efficient steel mining and production. They believe the future of metallurgy requires development across the region in which economically, ecologically and social aspect of the industry, and they take corporate responsibility very seriously. The company recently created the country's largest database with petabytes of data that were previously discarded. Cervestal is now looking for machine learning to improve automation, increase efficiency, and maintain high quality in their production. Now let's introduce the problem statement that we faced. Steel is, as we all know, that steel is one of the most important building materials of modern times. Steel buildings are resistant to natural and man-made wear, which has made the material ubiquitous around the world. To help make production of steel more efficient, this competition will help us with identifying the problems and the defects that any steel will face. Today, Celestial uses images from high frequency cameras to power a defect of all the steels, and it has an algorithm which is called defect detection algorithm. To be precise, it is basically a multi-classification problem to distinguish the type of defect present in steel. These projects aim to help engineers to improve the algorithm by localizing and classifying surface defects on a steel sheet. It is successful. If successful, we will keep manufacturing standards for high steel and enable Celestial to continue their motivation, leading to a stronger, more efficient world around us. Now I would like to tell you about all the problems that we faced. We had done several problems, but I would like to quote two. Firstly, a satisfaction one said all models are bad. It's just that some are useful. Finding the most useful model for a particular data set in one go is still a dream. We also faced the same problem. We started with a basic CNN model whose accuracy wasn't very good. And the other was pre-processing is a fundamental step during a deep learning model. During pre-processing stage, train CSV file of the dataset contains some images which had no defects, and because of that we have to run the files again and again, and which were overfitting our classifier to train our dataset on an empty mask.
Now let me tell you the approach we used to deal with the problem. To deal with the pre-processing problem, I decided to discard all of the training data that have all 4 masks missing. We will only train on images that have at least one mask, so that our classifier does not overfit empty tasks. We use the DenseNet 1-to-1 classifier to predict all of the test images that have 4 masks missing. We will automatically set the RLEs of the images to null. Secondly, as the problem told in previous section regarding the model which is required to be chosen, we will train the same model from simple Keras unit boilerplate on the filtered training data. Then perform inferences only on the test images that were not discarded in step 1. Now let me brief you to the chosen approach. Which model should be applied? You can't get to this answer very easily. You need to try and test all the algorithms numerous number of times. Our first model was a basic CNN model which wasn't much of use and gave an accuracy of 68 to 70%, which is very low. Now when we searched through the models, we found the unit model to be very useful for our dataset, and certainly our assumption was very true. The main idea behind CNN is to learn the feature mapping of an image and exploit it to make more nuanced feature mapping. This works well in classification problems as the image is converted into vector which is further used for classification. But in image segmentation, we not only need to convert feature map into a vector but also reconstruct an image from this vector. This is mammoth task because it's a lot tougher to convert a vector into an image than vice versa. The whole idea of unit is revolved around this problem. This computation is evaluated on the mean dice coefficient. The dice coefficient can be used to compare the pixel-wise agreement between a predicted segmentation and its corresponding ground truth. The formula is given over here, where x is the predicted set of pixels and y is the ground truth. The dice coefficient is defined to be 1 when both x and y are empty. So this was my rank in Celestial Steel defect problem. I am Harsh Katyal. So this was our final year project of machine learning. Code will be further uploaded to the GitHub account and link will be provided in the description below. Thank you for watching the video.